Oh, hi there. How are you? It's good to see you again. I'm glad you stopped by. Listen, I was just remembering that wonderful story you told me. So, as I recall, you were working as an accountant at that contractor, a building contractor, and you're in your office one day and you're doing the bank reconciliations. There's a knock at the door, and it's your colleague by the name of Selma. Selma says, I got a question. Can you help me out? Sure. What can I do? You were telling me. So, Selma has a daughter, Patty, graduating from high school with good grades. She wants to apply to a bunch of universities, some heavyweight universities. And the guidance counselor said, listen, Patty, you only have about a 10% chance of getting into these universities based on your grades and scores and etc. And, she went to her mother, which was your friend, Selma, and says there's 10 universities. There's a $300 application fee. I want you and Dad to pay the $3,000, $300 per application for 10 of them. And so she said, all right, let me think about it. So she spoke to her husband. They said, listen, we'd like to give her a good start. We'd like to give her a good chance. But $3,000 is a lot of money. If there's a better than 50% probability that she can get into one of those schools, we'll pay for it. But if there's less than 50% probability, they're going to decline and say, no, we're not going to do it. But she doesn't know how to calculate that. So that's why she came to you. What is the probability of her getting into at least one of those schools? So we can determine whether to pay the application fees. So you said, okay, I think I understand the problem. Okay, let's put it up here on the board here. So right here, we can see that the question is, the probability of getting into each and any one of the 10 schools is 10%. And if Patty applies to all 10 schools, what's the probability of her getting accepted into at least one? The probability of getting accepted in one school is 0.1. Therefore, the probability of getting rejected at one school is 1 minus 0.1 equals 0.9. The probability of getting rejected at two schools would be 0.9 times 0.9 equals 0.81. And the probability of getting rejected at all 10 schools would be 0.9 raised to the 10th power. You can do that on a calculator, or in Excel, you put in equals 0.9. There's like above the 8's little caret, that's the exponent sign. 10 equals, you hit enter, 0.3486. Therefore, the probability of getting accepted into at least one school is 1 minus 0.3486, or 0.6512. That's 65%. See, first we calculate the probability you're going to get rejected at all the schools, then you take 1 minus that. So your friend, your colleague was really happy about that. She says, 65%, that's good. I think me and my husband are going to front the money for that. So you're like, okay, I'm glad you could help you out. So the next day, you were telling me you get a phone call from the president of the company. President of the company, she says, listen, I'd like you to stop up. I got a question, I need some help. Okay, so you go up there. She sits you down in her office and she says, listen, I was having a conversation. I had lunch with Selma. She was telling me that you helped her out with her daughter regarding, the probability of college education. Sure. I have something that might be similar. I think it's kind of similar. We're thinking about expanding the business, and we want to put in these closed bid contracts. Now, a closed bid contract is, not a sure thing. Matter of fact, we think there's only a 5% chance of getting into accepted for our contract. How many bids would we have to put in for a 50% chance, and how many bids would we have to put in to get an 80% chance of success? It costs $5,000 for us to do all the work to come up with a good bid. So you said, I think we could do that. Here, let's put it up on the board. This is what you said, okay? You said, okay, the company, let's see, we got this right. The company is considering entering closed bids on a series of contracting jobs. It costs $5,000 to do the proper evaluating and estimating to prepare a valid closed bid. Estimate only a 5% chance of winning the contract. How many closed bids would they need to have to get a greater than 50% chance of winning? And how many for 80%? So the probability of success for each bid is 0.05. The probability of failure is 0.95, right? Just 1 minus 0.05. The total aggregate probability of success of just over 50%, right? So that means the failure would be just under 50%. So let's say 0.499, okay? So we're going to use logarithms. Okay, don't get scared. Might have been a while, but we're going to use Excel for your logarithm. We're going to take the logarithm of 0.499, that's the failure, right? With the base of 0.95, that's the probability of failure. So in Excel, you put in equals, log, open parentheses, 0.499, comma, 0.95, close the parentheses, you hit enter, and answer comes up 13.55. Okay, let's round that up to 14. You're going to have to enter 14 closed bid contracts. If you're saying they're $5,000 each, it's going to cost you probably about $70,000 for a slightly over 50% probability of success. And you also wanted for a slightly greater than 80% probability of success. So now you want the log of 0.199, that's just under 20%, right? That would be the failure. With the base of 0.95, that's the failure again. So equals the log of 0.199, comma 0.95. So that's 31.47. You're going to round up to 32. So you're going to need to enter 32 closed bids at, if it's $5,000 each, cost you $160,000 for an 80% probability of success. So the president's really pleased. She says, that's really interesting how you did that. First you came up with the probability of failure and then took one minus it. Okay, how about if I throw you a curveball? My people who are looking at the bids have 3 different scenarios. They want to put in 5 bids that have a 5% chance of success, 5 bids that a different place, 10% chance of success, and 5 bids with a 15% chance of success. What's our probability of success in the 15 bids? Okay, let's put that up here on the board here. So right up there, we put it up there, 5 bids with a 5% probability, another 5 with a 10% probability, another 5 with a 15% probability. So basically, we take the failure of the first 5 bids would be 0.95, raised to the 5th power is 0.7737. The probability of failure of all 5 of the second series would be 0.90, raised to the 5th power, 0.5909. The probability of failure of all 5 in the last series is 0.85, raised to the 5th power, 0.49937. You multiply all of those together, 0.7737 times 0.59049 times 0.4437, and that equals 0.2027. That's the probability of failing at all 15. So if that's the probability of failing at all 15, the probability of success would be 1 minus 0.20, or 79.7%. You round that up to 80%. You have an 80% chance of success under that scenario. 80%. So, President, I said, that's really fascinating. I never really understood that very much, but you did, apparently. So what did the president say? And, well, apparently the president was very pleased. She said, I think this is something we want to, get involved in. We're going to have to budget the money for the, the costs to get into these. And I want you to be my advisor here so we can make the correct calculations on what, is going to be worthwhile and what's not. I think there's going to be a promotion in there. So I said, that's just fantastic. Look at that. Once again, using mathematics to guide the management team in areas that aren't necessarily just your normal accounting duties. And that is why you are one ace accountant. All right, let's give you a round of applause, all right? Good for you. All right.